Students, let's start with circles. So here in this chapter, we come across with two important theorems. So these theorems are also very important, which you need to cover prior to having the solutions directly, as they are the basic which gives us the statement how to start out and what to be written during solutions. So let's move out with that. So the first theorem states that the length of the tangents drawn from external point are equal. So length of the tangent from external points are equal. So what does this theorem states? We need to make that these two tangents are equal. So here we'll be making two triangles congruent. Already in 9th standard, you read that congruency chapter. So the same thing we are following here. 9th standard, 7th chapter, if you recall back. So here it is given circle with center O. P is exterior point from where two tangents PQ and PR are drawn. So here O is the center of the circle. P is an exterior point from where two tangents PQ and PR are drawn. Construction join OP. So this OP is joined. Now we need to prove PQ is equal to PR. Okay, that is PQ and PR are equal. That we need to prove. For your convenience, I started with the diagram again. So in this diagram, already you know that tangents, the point of contact is perpendicular. So angle Q and angle R will be 90. So we're starting with two triangles. Triangle PQO. PQO and triangle PRO. So in these triangles, concentrate on the diagram and statements which we are following. So here, the first one, OQ is equal to OR. So each one is radius. They are drawn from center. So both the lines are radius. Now the second one, angle Q is equal to angle R. So Q and R both are equal. Reason is each one is 90. They are making perpendicular, so each is 90. Third point, OP is common. We got 3 points. One is radius, other is right angle, third one OP common. If you recall back RHS theorem, there we need to make one angle to be right angle, hypotenuse to be constant, and one side. R stands for right angle, H stands for hypotenuse, and one for side. So here we got three conditions. So both the triangles are congruent by RHS, congruency rule. So as the triangles are congruent, PQ is equal to PR by CPCT. Now PQ and PR are nothing but tangents. So the final statement will be tangents are equal from an external point. So this is how we completed the first theorem. It's very easy, and this point we are using in the chapter very often. Statement you need to memorize properly. Tangents are equal from an external point. So this they can ask either in the form of theorem or sometimes in the form of proof, or in questions, solutions, many times, like very often we are going to use this, that the tangents are equal. Now coming to the next topic, where we need to make that the point of contact is perpendicular. That is the next theorem. So here 10.1. Two theorems are there, 10.1 and 10.2. Both you need to learn properly. 10.1, it is given tangent perpendicular at the point of contact. So here we need to make the point of contact this perpendicular. Here the given statement. Vivek, is it clear first theorem properly? Vivek, first one is clear? Are you there? Can you hear me? Okay. Now circle with center O and XY is tangent. So here there is a circle with the center O and XY is tangent. We need to prove OP is perpendicular to XY. So this was the proof that OP, the point of tangent, that perpendicular to the point of contact. So we need to make OP perpendicular to XY. Now let's start out with construction. Take point Q other than P and join OQ. So here we are taking point Q which is other than O. Another point is taken and join other than P. So at the point P already it is in contact. So leaving P, take another point Q and join OQ. Here proof Q is outside the circle. So obviously from the diagram Q is outside. So what we can say about that? Q is outside the circle. If it is inside, XY will become secant. So what we call secant? If the line is passing out from inside the circle and crossing it, we call it as secant. So here, if Q is inside the circle, it could have become secant. XY will become secant, but OP is the shortest side. So yeah, it could have become secant, but now it is outside. Okay, it's not inside. So we'll write like Q is outside. Therefore, XY is tangent. As XY is tangent, OP is the shortest side among all the sides. So finally, OP is perpendicular to XY. So these theorems are there in the textbook. Refer them and learn it properly. So both the theorems are important. Now we'll move out with the questions here. Okay, yesterday we started few questions. So let's start out with the topic. If you recall back, yesterday we did like tangents are making supplementary angle at the center. So instead of that, yesterday I advised like we should follow a sequence which will make it easy to understand rather than simply doing the questions randomly. If you follow out sequence, it will be easy for you to learn. So once you mark out the questions, which could be here in MCQs, we have one property which is very important property for MCQ. Angle at the center and angle at the external point, they are always supplementary. Here there is a proof for this question also. The same question is there in exercise to prove that, and in MCQs we are going to use this property. For this kind of MCQs, they will be giving any one angle. So here three varieties of questions could be there. The first one, like if they have given the center angle as 70, center angle as 70, they can ask what is the exterior angle. Sum of both the angles is always 180. Let this be O and let this be P. As per the property, O plus P is 180. If O is given 70, will you say answer? Okay, what do you want me to explain again? I'll be explaining complete chapter. You just said like please explain again. What do you want me to repeat? Will you say what you want me to repeat? Okay, so here second theorem you want me to explain again. Okay, so I started with this property. So in the end we will move back to again. Here when we add both the angles, sum is 180. So if one is given, we can find other. 180 minus 80, 110. So in this type of question, they'll be giving the different varieties like here these angles get bisected. Very good, 110. So angles get bisected. In the theorem we came across, if we join this line, the angles, both the triangles are congruent. So this angle and this angle is equal, and this angle and this angle is equal. They'll be giving any one angle and they'll ask to find out complete. For example, if suppose they have given this part of the angle as 40. Can you find out what is the complete center angle? What will be the value of the center angle? So here, if one of the part is given, we know that both the angles are equal. If this is 40, this will also be 40. 40 plus 40, 80. Very good. So this will be 110. So in that way, they will be giving any one out of the four. They'll ask to find out other. So this is one kind of question. Now how we got this proof? Okay, like both are 180. That's in your exercise question number. Prove that the angle between the two tangents drawn from question number 10, okay, of your exercise based on this property. Exercise 10th question. Okay. So here the question is, prove that angle between the two tangents drawn from external point to a circle is supplementary to the angle subscribed by the line segment joining the point of contact. So here line segment joining the point of contact is this one. Angle between the line segments joining the point of contact and angle between the tangents. We need to make that to be supplementary. P, Q and R. So how you have this proof? It's very easy, only 2 steps. So here we'll start like we need to given circle with center O and PQ and PR be tangents. So there is circle and 2 tangents are there. To prove angle QOR plus angle QPR is 180. We need to make them supplementary. Now proof. In quadrilateral, you can see here a quadrilateral. Quadrilateral is a polynomial which is made up of 4 sides. In quadrilateral OQPR, angle O plus angle Q plus P plus R is 360. Out of which we know that angle Q and R are, will you say answer? What is the value of Q and R? Waiting for your response. Will you say what is Q and R? Vivek, what is Q and R? 90. So here angle O plus 90 plus P plus 90, 360. How we got this 90? We need to write the statement. Point of contact to tangent is perpendicular. Now angle O could be replaced by QOR. 90 plus 90 is 180. Angle P with QPR. So we got 2 angles. QOR plus QPR is equal to, okay, I'll get pen, 360 minus 180. So ultimately it is 180. So this is the first proof which we got. Angle QOR plus QPR is 360 minus 180. So thus it is 180. So we can say that angle at the external point and center are supplementary. So this we completed first one. Is it clear? So our 10th question got completed. So whatever the property we'll be using, we'll solve question according to that. Is it clear? Getting no response. Is it clear? Okay. Now the next question, where question number 8 is important one. So I'll start from that. Question number 8, diagram is given and there is a quadrilateral circumscribing a circle. So quadrilateral is there and inside that a circle. So based on this, they can ask some short questions. Try to learn basics of this question. So how we are going to prove this? So in this question, it's given a quadrilateral ABCD is drawn to circumscribe the circle. Circumscribing a circle, a quadrilateral is drawn. We need to prove circle with center O. We need to prove here always opposite sides sum will be equal. So AB will be equal to CD, AD will be equal to BC. We need to prove AB plus CD, sum of opposite sides are equal. AD plus BC. So here we are making sum of opposite sides equal. So how the proof begins? You need to remember, like, we'll start from any one corner. So it's your choice. You can start from any of the corner. So here I'm starting from this corner. As tangents are equal and these two are tangents, so I'll make it AS is equal to AP. This is my first equation. You can start from any of the corner. I have chosen this corner. AP is equal to AS. And here the statement will be tangents are equal from external point. First proof, first theorem. Okay, that statement we will write over here. Now this is the first equation. Wherever the side got ended, see here, AP is there. The remaining part of AP is BP. You need to make one complete side. We had here AP, so the remaining part to be added. AP is towards right. So next side will be BP. So we'll take BP is equal to BQ. BQ comes this side. So side we need to make complete. Okay. AP I completed with BP. So BP's remaining side will be BQ. Now BQ and CQ will make BC. So BQ's remaining side is CQ. So there we are going to add CQ on the left side and the remaining one, that is CR, on the right side. This is our third equation. Now again make the side complete. So here we got CR and CQ. Now CR's complete side is DR. So add DR on the right side and tangent DS on the left. Once again repeating, I started from this corner. So AP is equal to AS. Now AP's remaining part BP. Instead of taking BP here, you can complete AS also. If you want to complete AS, you will be taking DS. If you choose DS, DR to be taken. Whatever the side you are rotating, just keep in mind, like, you need to make the side complete. Is it clear? Vivek, is it clear? Vivek, is it clear how I took sides? Okay. Now the next step is adding equation 1, 2, 3 and 4. If we add all the equations, right on the left part together and right part together. Now the next one, AS plus DS. AS and DS will make AD. So write them together. Arrange the sides which are making one complete side. And the same way, AP and BP, that also makes one complete side. So AP plus, okay, AP and BP is there here. Okay, AP and BP, CR plus DR. Now write down their complete sides. AS plus DS, it's AD. BC is equal to AB plus CD. So this we completed that. Some of the opposite sides are equal. So this was question number 8 of circles. Now interrelated question of 8 is question number 11. So once if you learn question number 8, the soon continuation, like while practicing, you should go for the next question, which is 11th one. In 11th question, it is given, prove that parallelogram circumscribing a circle is rhombus. Here it is given, prove that parallelogram circumscribing circle is rhombus. So we need to prove that to be rhombus. So here circle is there, then a parallelogram is there. So this parallelogram we need to make rhombus. Again the same way, ABCD, then PQRS. Whatever we did in the previous section, all the things to be repeated. The same content we will repeat, same as it is. Okay. After completion, we reached till opposite side sum. Till there, the sum is as it is. AB plus CD is equal to BC plus AD. Till here, we need to continue in the same way. Now, as in the question, it is given ABCD is a parallelogram. We know that in parallelogram, opposite sides are equal. So here both are opposite sides. So we can write AB plus AB is equal to BC plus BC. Here the statement will be like opposite sides of parallelogram are equal. So as the opposite sides are equal, we made CD as AB. Now AB is twice, BC is also twice. 2 times AB is equal to 2 times BC. Thus 2 got cancelled. AB is equal to BC. But AB and BC, they are adjacent sides. In a parallelogram, if adjacent sides are equal, we call it as rhombus. Difference between rhombus and square, if we make adjacent sides equal, it's rhombus. Along with adjacent sides, if we make the adjacent angles 90, then it is square. They're asking to make it rhombus. So we do not worry about angle. So the final statement, as the opposite sides are equal, so we'll write like, but they are adjacent sides of parallelogram. So this is symbol of parallelogram, or you can write complete spelling, 2 parallel lines and G and M. As they are the adjacent sides of parallelogram, therefore ABCD is a rhombus. As we made opposite adjacent sides of the parallelogram equal, so ABCD will be considered as rhombus. Rhombus is a parallelogram with adjacent sides equal. So here we got the continuation. If you practice question number 8, soon complete question number 11. They both are interrelated. Okay. 8 you need to continue with 11. Okay. If they will ask till here, leave there. If they will be asking make it to rhombus, just in the side, we will make like, as it is a parallelogram, so opposite sides will be equal. So we'll replace CD by AB and AD by BC. Then adding the sides together, like 2 times AB is 2 times BC. Finally, AB equal to BC, but they are adjacent sides. So rhombus is a parallelogram. So this we completed. Is it clear? Is it clear? Vivek, is it clear? Shall I move to next question? Okay. Now based on this question, how they can ask MCQ? So based on this question, next MCQ could be like, they'll not give diagram, they'll be just giving out sides. They'll give like AB plus CD, as we have sum of opposite sides equal, AD plus BC. So they'll give like AB 4, BC to be 8, this to be 6. What is the value of AD? So like that, 3 sides will be given. They'll be asking for the 4th side. So how we are going to find? As it is MCQ, add both the sides, subtract 3rd side from that. Adding these 2 sides, subtracting 3rd side from that. Whatever the opposite sides are given, add them, subtract the remaining one. Will you say answer? Will you try for answer? Okay, very good. So this could be one MCQ. Now one more question is there based on the same property. Okay, so here the question is there, circle touches all the 4 sides, AB is 5, BC is 8, CD is 6, find AD. So AB 5, so I'll write over here only, AB 5, BC 8, then CD 6, okay, same only they gave. Instead of 4, 5 they have given. So what will be the answer? Instead of 4, it is 5. Okay. Will you give answer? Instead of 4, if it is 5, what will be the answer? 3. Good. Now the next question. In quadrilateral ABCD. ABCD is a quadrilateral. Angle D is 90. Somewhat like this. And there is a circle. Like the circle is there. Okay. Angle D is given 90. Here the sides are given. BC is 40. CD 30. BP 25. So circle touches AB at P, BC at Q, BP value is given 25. Find the radius of circle. You need to find radius. So how we are going to solve this question? Here the value of BP is given 25. As we know that tangents are equal, so this part will also be 25. BP is equal to BC. BP and BC are equal, so they will be 25. If this part is 25, can you find out CQ? Complete side is 40. If this is 25, what will be the value of CQ? Will you say PR? Why you wrote PR? I can't understand. Okay, I'm explaining just to pay attention. This part is given 25. So this will be 25 as tangents are equal. Now subtracting 25 from 40. So this is 15. Very good. If it is 15, this will also be 15 as are tangents. Now we can find out the remaining part of this. If it is 15, this will also be 15. 30 minus 15. So we got the value of 15 here. See here these two are perpendicular and moreover these are tangents. If we drop a perpendicular from the center at the point of contact, that is also perpendicular. So here this is also 90, this was 90, and next here we got two adjacent side angles 90 and adjacent sides are equal due to tangent. If you recall back, few minutes back I said like if a quadrilateral is there where adjacent angles are 90 and adjacent sides are equal, we call it a square. As now this part became a square, so radius will be 15. Square have all the sides equal. So this is one more MCQ. Though it is looking like very complicated sum, but solution is quite easy. Understood it properly? Here, basically we are using tangent property and tangents are equal from external point. After completion of the diagram, you just need to see that how you are making the tangents equal and calculating the remaining part, and sum is getting completed. So is it clear, this question? Now next, one more question which I explained in the previous class, like where we used incircle radius. If you recall back, I told you like incircle, if ABC is a right angle triangle, how to calculate in radius. For that I said add both the smaller sides, subtract third side, divided by 2. Okay, how we did the formula? AB plus BC minus larger side divided by 2 is in radius. So how we proved that? This is also proved based on tangent property only. So here in proof, write down that. So in proof, divide by 2 will also come, okay? So in proof, we need to find out the tangent relationship. Select the circle touches the three sides at PQR. So we'll start from any one corner as we did. For this, you keep in mind, so this is the important thing you need to keep in mind. So from where you are going to start, okay? You will be starting from smaller side, okay? As we need to subtract AC, so we'll be starting the largest side. So here AC could be written as, how we can write AC? AQ plus QC. So this is extra question, okay? This is not from the textbook. AC is equal to AQ plus QC. AC is equal to AQ plus QC. Now we can replace AQ with AR, as AQ and AR are tangents. And the same way we can replace QC with PC. Is it clear up to here? We replaced AQ with AR and QC with PC. After that, AR could be replaced with AB minus BR. AR is complete AB minus BR. So replace AR with AB minus BR, and in the same way PC with BC minus BP. These all are equal to AC. In the previous question I told like BP and BR are equal to radius. So that proof, once again I will write you how we made this to be equal to radius. That also you need to add out in the solution. So here AB keeping as it is, BR we are replacing by R, BC as it is, BP we are replacing by R. So here 2 times R is there, shifting towards right side. 2 times R, it will become positive. AB plus BC, shifting AC towards right. So it's minus AC. Thus the radius is AB plus BC minus AC by 2. So this is nothing but in radius. This is how we got the value of in radius. Along with that, what extra you need to add? So as I told, like it is a right angle triangle. So you will be writing like in quadrilateral PBOR, PB is equal to BR. Both are tangents. Angle B is 90. Angle B and angle P 90. Therefore, BPOR is square. So as we made it square, sides will be equal. Therefore, BP and BR will be equal to radius. So here the statement, sides of the square are equal. Sides of square are equal. So we use this property over here. So this is the important one which very often asked in MCQs. Simply we need to add two sides where they will ask find out in radius. So here we'll be adding both the smaller sides. From there the larger side we subtracted and divide by 2. So based on this property I'll be giving one MCQ. Find the answer and state it fast. So here AB is given 24. Excuse me. AB is 24. BC is 7. Then find radius. Here the third side is not given. By Pythagoras theorem, you are going to calculate third side. AB is given 7, BC is 24. Find out the third side and in radius. So waiting for your reply. Complete it. If you are not getting, I'll explain solution once again. Can you solve it? Vivek, can you solve it? Vivek, will you do or you want me to explain? Okay, will you solve it? So how we did this? In radius you got 3. Now let me check. 7, 24. So third side by Pythagoras theorem will be 25. We need to find radius. So radius will be 7 plus 24 minus 25 divided by 2. So it's 31 minus 25, 6. 6 by 2 is 3. Very good, correct answer. Now you understood this property, no? Now, very often they ask one more property where, like we know that tangent touch the circle at external point and that too it points of contact is right angle. Here they will be giving any two sides and they'll ask to find out the third side. In this question, radius is given, P lies in exterior point and so here OP is given 13, radius is given 5, find PT. So simply we'll be using here Pythagoras theorem where we can find out PT's value. So will you say answer? Will you say answer? OT is given 5, we need to find PT value. No, it's wrong. They are triplets. 5 square plus PT square is OP square. No, 14 is wrong answer. PT square is OP is 13. 13 square minus 5 square. 13 square is 169 minus 25 is 144. Now it's correct. Root over 144 is 12. So PT is 12. This we got the value of PT. Very good. Correct answer. Now the next question. The same kind of question I'm giving one more. P is exterior to the circle. Radius is given 15. Now the radius is 15. PT is 8. Calculate. So this has to be on the corner, okay? Draw it properly. So this is given 15. This is 8. We need to find OP. Say answer fast. You got it? 13. 15 square is 225. 8 square is 64. Again wrong. 289. Root of 289 is 17. It's not 13. Correct answer is 17. It's not 13. You need to learn the squares. Not 27. 17. 15 square is 225. 8 square is 64. If we add them, it's 289. Root of 289 is 17. See here, for having the better calculation, learn squares up to 20 at least very perfectly. Okay, very often we use them so that to be memorized thoroughly, to have the quick calculations. For MCQs, you will not be solving all or the complete calculation will be done. So for them, it is better to learn the roots where you can solve it easily. Now the same property, one more question. So here it is given angle, circle is there, angle at the center and angle at the corner. PA and PB are the tangents. Center is O. Angle AOB is given 80. You need to find the angle OPB. Find OPB. No. OPB you need to calculate. OPB, don't get confused. OPB is half of this angle. If it is given 80, complete angle is 100. OPB will be half of that. So it's 50. Got it? So what they're asking is very perfect to you. Be clear with that. Make the clear diagram, then go for solution. If they'll ask complete angle, directly subtract from 180 and say the answer. If they will ask half of the angle, we need to divide it by 2. Now one more question. Tangent P is from the exterior point where OP is 13, PQ is 8. Find the diameter. Listen carefully, don't get confused. So here tangent is there from the external point. OP is given 13. You need to find diameter. So what will be the value of diameter here? Is there anyone who can say it perfectly? Okay, some of you gave that 50 degree. Nice. Someone else said the answer 50. Very good. Now it's correct. Diameter is 10. So how we got diameter 10? Very nice. Those who are giving answer. Again, the triplets are there. If 13, 12, this will be 5. May I know your name? Just now who wrote like diameter is 10, so that I can call you by name. 13 and 12 is there. So 13 square is 169 by Pythagoras theorem. Very nice. So we got it 5. As I asked about diameter, diameter is twice of radius. So it's 5. Okay, very good, Arnav. Now the next question, triangle ABC, where the sides are given. I don't know whether you was there in the previous question when I explained about in radius. Okay, I don't know whether you was there. Here the value of AB is given 3, BC is given 4 and AC is given 5. We need to find what is in radius. Calculate in radius. So I don't know, Arnav, whether you was there or not when I explained about the formula of in radius. If you was there, it's well and good. If not, I'll say the formula. Please see it. To calculate in radius, add, listen carefully and give me answer. Okay, you already given. Okay, you have given answer. Let me explain. 2 bigger sides to be added and smaller side to be subtracted. So here 5 plus 4 is 9. 9 minus 3 is 6. 6 by 2 is, have you got 1? 1 is wrong answer. Add both the bigger sides. So 5 plus 4, subtract the smaller one, divide by 2. So it's 9 minus 3, 6. 6 by 2, 3. Don't get confused. Okay. So here you need to learn it very properly. That's an important MCQ. Only keep in mind like bigger sides to be added, smaller one to be subtracted, divide by 2. That is the formula of in radius. Even the proof was explained. So as you was not there, Arnab, and you are giving very frequently correct answers. So once you go, can go back where the proof of this is explained in today's session only. Okay, next one more question is there. You need to find length of the chord. Okay. So I'm giving the hint. What is chord? Chord is a line segment which touch the circle at two ends. So here radius is given 5 and there are two circles who radius of their 3 and 5. You need to find length of chord. So how to find length of chord? If two in circles are there are two circles with the centers. In circle means the circles having same concentric circles. Sorry, repeating once again. Two concentric circles are there with radii 5 and 3. Find the length of common chord. So how we can calculate common chord? If it is given two circles are there with the same radius, like you'll be drawing with the same center, two different radii. If they'll ask to find the length of chord, we need to find this chord. If you remember in 9th standard, this question was there in circles. Very good. 4 is the correct answer. 4 is not, 8 will be the answer. So once I'm explaining, see here, 4 plus 4, 8. Very good. So here the radius is given 3. Vivek, answer. Radius is given 3 and the next one is given 5. By Pythagoras theorem, we will calculate what is the other side. 5 square minus 3 square. 5 square is 25 minus 9, thus it is 16. Root of 16 is 4. Chord get bisected if we drop a perpendicular from the center. So this part we got 4. They are asking what is the length of the common chord. So chord will be 4 plus 4, 8. Vivek, correct answer. Okay. Nice, correct answer only. Okay, this was there in 9th standard. Now, question number 9. Question number 9 is also one of the important question which you need to solve. So, question number 9, it is given xy and x dash are the parallel lines. So, here there is a circle and two parallel lines are there. xy and x dash, y dash. One more tangent is there. O, B, A. Here this point is A, point C. In this question, we need to prove angle AOB is 90. So this is also very important question. So how we are going to solve? Once again, I'm reading the given part that I'm not writing. You can write by your own. xy and x dash y are two parallel tangents to the circle with center O, and AB is another tangent. So that will be in the given part. xy and x dash y, they intersect the circle at A and B. And C is also the point of contact. So all these are given in proof. Join OC. Very good. So the construction is join OC. So here given, you need to write by your own. This is to proof, construction, join OC. Let's start out with the proof part. Here we got two triangles. So this we need to make congruent. So question number 9 and question number 13 are interrelated questions where we are going to use the same property. 13 yesterday we already did. So here explaining your ninth one. If we join OC, we can make the triangles congruent. Let this be is given P and Q. Now proof in triangle PYO and triangle CYO. So here the sequence to be followed perfectly. First point, OP is equal to OC. Will you give reason how OP and OC are equal? Will you give reason how they are equal? OP and OC? Each one is radius. Now the second point, angle C is equal to angle P, 90. Very good. They are 90 point of contact. Now coming to third point, OY is equal to OY. They are common. So here we got 3 points. OP is equal to OC. Each is radius. OY is common. And these two are tangents. So therefore, triangle PYO is congruent to triangle CYO by congruency property of RHS, as we used right angle, hypotenuse and one of the side. So they got congruent by RHS. Once if the triangles are congruent, by CPCT we can make other sides like other properties equal. So make the angle O as 1 and angle 2 as the remaining part. So angle 1 is equal to angle 2 by CPCT. So as we made angle 1 and 2 equal, similarly we can make this triangular part also to be congruent, where let this be 3 and 4. So here after completing the first triangle congruent, we can make angle 3 equal to angle 4 similarly by CPCT. Now adding first equation and second equation. If we add them, adding equation 1 and 2. First equation. So if we add, okay, adding all together, don't make first and 2. 1 plus 2 plus 3 plus 4 is equal to 180. They are making a straight angle. We can see straight line is there. So they are making straight angle. Don't write here linear pair. Linear pair gives only the value of 2 angles. So here we will be writing straight angle. So by straight angle property they are equal. Now angle 1, angle 2, 3 and 4. Replace the angles and whatever angle you will choose in the center, bring them in terms of that. Here I have taken 1, 2. Your choice may be different. Keep in mind like whatever the center angle you considered, you need to bring them in that respect. So here angle 2 and 4 to be chosen as the center angle by me. So I'll replace 1 by 2. So that angle I'll be writing twice, whatever I have chosen the center angle. So as I have taken central angle as 4, so I'll repeat it twice, is equal to 180. So this is how we got from equation 1 and 2. As already we made them congruent. So they are equal. Thus 2 times angle 2 plus angle 4 is equal to 180. So they'll get cancelled. So finally angle 2 plus angle 4 is 90. If we go back, angle 2 plus 4 is nothing but AOB. Now replace that with AOB. So finally angle AOB is 90. This is only we need to prove. Is it clear? This is also important question which you need to practice properly. Already we did that concentric circle one in your textbook also, 7th question that is there. So from exercise, we completed 7th question, 8th question, 9th, 10th, 11th is done. Yesterday I explained 12th, 13th also done. So almost all the questions got completed. Only the starting one are remaining, which you can do by your own. MCQs are there. Already we did. If you recall back, see, it's given 110. This will be 70. Then this is based on Pythagoras theorem, 24, 25. So other side will be 7. As the triplets are 7, 24 and 25. So this is based on the angle. This is also based on angle. So that also got completed. Only 2 questions are there which you need little practice. So that I will explain in tomorrow's class. So next all be completed. Almost everything is done. So once you go through with the exercise, those who are attending, if still you feel like anything is difficult which you want me to explain again, so that I'll be explaining. One question is there which is very nice, very beautiful question. You try for that, which is similar to question number 12 of your textbook. Okay. Here it is given, circle touches the sides AB, AC and AB of triangle BC, AC and AB of triangle ABC at DEF. Okay, so I'll draw and give so that it will be easy for you to do. So once you take out question and try for that. Here the circle which touch the 3 sides. A triangle is there. Circle touches it. AB, C is the triangle. Circle touch it at D, E and F. BC at D. BD is given X. CE is given Y. BD is X, CE is Y, and AF is Z. AF value is given Z, this is given X, this is given Y. You need to prove area of triangle. It's under root XYZ, X plus Y plus Z. This you can learn as formula also for MCQs. Okay. Sometimes they give the sides and they'll ask to find out area, or sometimes area will be given and they'll ask to find out missing side. From this formula directly you can calculate it. So this we need to prove. Can you do it by your own or you want me to explain? So say fast, time is getting over. I have another class. Say it fast. If you solve by your own, it's okay, otherwise I'll explain. Will you say what you want? Okay, I'll solve by own. Shall I wait for you? Arnab, are you new? Attending my class for first time? So the first time I'm seeing you. Are you a 10th standard student? Arnab, are you new? Attending my class for first time? Thank you. Nice for attending. If you liked my explanation, please like and subscribe my channel. And attend it regularly. Every day we have class by this time. I start usually by 4:30 to 5:30 or 5:40 around I'll be having maths class. So if you liked, you can continue to attend. Okay, I'll complete with explanation as I'm getting over with my time. So I have another class. So let's start the explanation. So this we are going to use tangent property. BD is X. So BF will be X. Thank you. Nice statement I got after a long. So your X, CE is Y. CD will also be Y. AF is Z. AE is Z. So by tangent property, we got all the four sides. Now find out semi-perimeter. So as we go for Heron's method, semi-perimeter S is equal to, in the previous class, I already explained like all the values will be twice. Instead of writing all together, we can take 2 common. So it will be 2 times x plus y plus z by 2. So your 2 got cancelled. We got the value of semi-perimeter. Now area of triangle is root over s, s minus a, s minus b, s minus c. So here value of s is x plus y plus z. Again s x plus y plus z. We need to subtract a. Any of the side you can choose as a. So if I have chosen BC as a, it will be x and y. So minus x minus y. Now the next one. Okay. Again x plus y plus z. Next side is z and y. Minus z minus y. Third side x plus y plus z minus x minus z. Now cancel them. So here xy got cancelled. Here z and y got cancelled. So we left out with x, here with z, here with y. Now we reach to our proof. So finally area is xyz in multiplication with x plus y plus z root over. So this is area. This only we need to prove. So in previous years question paper, this was there where they have given the area value and they asked about to find out one of the side. One of the side was missing. So let's try for this. If suppose the triangle is there, okay, and here a circle is not needed at all. If for radius we need like tangent. If it is given 7 and 6, 7 and 6, how to calculate the remaining side by using this formula? If they will give okay, if they will give a side can be calculated by using this. So this kind of question they will be giving side where we can calculate other. Few more questions are there, important questions of this chapter. Meanwhile, like those who have extra questions can share me to my WhatsApp number. In our next session, we'll deal out with all those questions. Those are having sample papers, or if any questions from your school exams, whatever were conducted, if you felt it difficult, you can share it to me in my WhatsApp number. Then we'll have explanation for that. Okay. As you are new, you can take my WhatsApp number. So this is my WhatsApp number. If you have any queries, you can contact to this number. In my next session, I'll deal with all your difficulties. Whatever chapter you are having difficulty, you can just send me message. In the next class, we can have that. I'm a science and maths teacher. So whatever questions you are having regarding science or maths, you can get solution. Even English grammar I can deal. So whatever subjects you want, if there will be supporters, if the response will be there, a teacher will feel like to answer. Okay, so during my class, if there will be answering, definitely I'll deal with all the difficulties. We are having till like 1.5 more month is there, which is very much sufficient for the 10th revision. You can get the explanations. So whatever the difficulties are there, come across with that. So I'll try all to clarify. You are from which school? If DAV means they'll be giving like high level of questions. Rather than that, if it is KV, sometimes we get the typical questions. Okay, now the time is like getting over. I'll wind up my class. Okay. I never heard this name. Huh? From which city you are? From which city you are? So long, nice. You are in top of the corner of the map and I'm in the completely bottom. I'm from Andhra Pradesh and you are from Jammu and Kashmir. It's very nice. Okay, nice to meet you. Nice to talk to you. Share your difficulties. Definitely I'll solve them. My WhatsApp number is with you. You can send them. Okay, thank you for attending today. Thank you all. So winding up my class now. Tomorrow again, get ready by 4:30.